Hi, everyone. My name is Tom Van Norman with the ICS Village and Grim. Running track 3 for today of Hack the Capital. Appreciate everybody's attendance to the conference today. Dan, Gunter, and I, we are up next for our presentation. Dan and I put this presentation together over the last few weeks to talk about some ICS hacking here. So we're going to go through an attack and then show everybody how to avoid it, how to detect it, things like that. So a little bit about me. I'm the co-founder of the ICS Village, along with Bryson Port. He's running track 1 right now. I do that part-time. ICS Village is a nonprofit organization run by volunteers and supported by our fabulous sponsors or partners. During the day, I work at Grim and I run the cyber physical products business line at Grim. Dan?
Thanks, Tom. So my name's Dan Gunter, and I'm the founder and CEO of Insane Forensics. We do a lot with scaled memory, disk, and network analysis, and a lot of threat hunting type stuff. Before that was with Dragos, and previous to that was actually in the Air Force, just like Tom. So back over to you, Tom.
Thank you. So we put this video together showing a hack just in the end of last week.
I'm not sure if you're showing the right screen, by the way. I see your keynote window if you're screen sharing.
I am screen sharing, and it says keynote, and it says run, and
now you're good.
You good now? Okay. All right. Sorry about that. Anyway, we have a video here of what would happen or what could happen with an attack on a control system. We're using the ICS Village range here that we saw on the live feed before. The purpose of this is to show what could happen. Then we're going to walk through on how to detect it, how to follow up with all the network traffic, the forensics part of it, and how to prevent it from happening. So operators watching the screen here, or watching the process via an HMI, all of a sudden the tank starts to overflow. Somebody changed the set point, or somebody did something to the network. Really don't know what happened to the network, what happened to the process just yet. But we do know we got somebody changed the level set point. We got some alarms in. The tank did not overflow, the process flow did not go on the ground, but the tank shut off once it hit the high level switch. Important part to remember as we go through the presentation. And there, the tank drains out because it hit the high level switch. So what are we looking at here? Here's a human machine interface, or HMI. This is where the operator will get a graphic representation of the process. So we have our tank with a level on it. We have the off and on controls for the pump. We're interfacing this HMI with multiple different PLCs. So we have Modbus, we have S7Com, we have Ethernet IP. This is where if somebody gained access to the HMI via local, via remote, however, they can control the entire process. Our alarms come in, our reports are created from this asset. So it's a pretty important asset to protect and to have access to. If you shut this off while your process is running, you can't control your process. You don't have any idea what the set points are, what the feed rates are, and things like that. Dan, over to you.
Awesome, thanks. So at this point, we just know something happened. We don't know if this is one of the cyber squirrels, if it's, another event. We don't know if it's cyber related. But something we can do, and something that we did to start with this, and I'll point out that everything I show you, we actually did with PyShark. So this is all open source T-Shark stuff. Yes, we will open source some of the scripts soon under the T-Shark terms. But you see, in some of those scenarios we run, depending on the buttons you hit, to the point of the slide that Tom showed, each have different protocols that they're actually using to talk to the PLCs. And when we were putting together these talks, something we wanted to show was, hey, in the scenario you see on the screen in the boxes in red, this was someone just kind of randomly clicking on the HMI. And you can see when you actually take that traffic and model it in something like Elk, you see that nice anomaly of the spike in the sends. And then in this case, this was us actually turning the system on and off repeatedly. You see the comms die out during the event. Where this is helpful is, again, it shows to where you can begin to bring in network monitoring, and you can begin to not just say, hey, there was an anomaly, but hey, let's actually kind of figure out, or let's correlate that physical event with the process with packets on the network. Next slide. So like I said, we see that spike up and then you see that dip down. And what's nice with this too, when you do actually start to look at network traffic, is you can get it down to the IP addresses that are actually responsible. So with HMI, Tom showed there's really only 2-3 PLCs. And in this case, you see there's 3 IP addresses. And we'll talk about those in the next slide. So next slide. The context of these 3 IP addresses, the HMI that Tom showed, that's the 100 one on the network. And then you have your PLC that's speaking Ethernet IP and Modbus. So that's to give some context on, hey, we saw the spikes. Now we know what the spikes were between. Let's dig into one of those boxes and next slide. So when you look at MITRE Attack, what this is using ICS attack. This is that manipulation and control. And we've seen groups do this all the way back to the S word, Stuxnet, all the way up to Ukraine 2015. Same deal where at the Ukrainian generation station, they have the video that you can still find online of the mouse moving around. That's kind of what we might see play out in our scenario. So next slide. So at this point, we just know there was manipulation of control. We know that there was that spike and then something bad happened with the process that caused that water to go everywhere. But we still don't know what caused it. So next slide. We're going to look at that. So something we might look at, and why we took those 3 IP addresses out, is, hey, let's look at traffic to the HMI during the time frame. And again, with the network analysis, what you can begin to do is say, hey, let me look at weird traffic going to that HMI, and especially time bounding it. So in this case, if we looked at 3389 at RDP, we saw that spike in TLS, and which the RDP session data is encrypted these days in port 3389. So we know at the same time there was a process event. Using the same type of graphing of network data, we can say, okay, someone RDP'd. We can't see what it was because it's encrypted, but we can see that it happened at the same time. Next slide. And again, you shouldn't just limit yourself to network data, because again, that network data is encrypted. What isn't encrypted is the Windows event logs. So what we did is we pulled the Windows event logs from the .100 box. This is what it looks like. And same deal, when you look for those spikes, and the spike circled in red, for those familiar with Windows event logs and those not, you can actually look for interactive logons or the lockout or the unlocks across the network. So, using the same graph, now we have, hey, someone unlocked the HMI remotely at the time of the event. Next slide. And again, this is what you might load into Elk when you actually do load the event logs in. And there actually, if you look, there's a Dragos blog out there. We open sourced, it's a Python library called ebtx to Elk. You can use that library to actually load these event logs into Elk. And so what you see here is you have your 4624 log, which is your window login. Now we know it was the SCADA user halfway down the other arrow that did it from 100.23. So we have another thread of this incident that we've kind of unraveled. Next slide. And so when we look at MITRE tactics here, we have another one, T1021.001. This is actually on the enterprise side. So abusing remote services. Groups doing this, and RDP is the common one that gets abused. If you look at groups doing this, it's just about every kind of major acting in interest of nation state group doing it. So yeah, one common, this is a very simple way, what we showed is a very simple way to find abuse of RDP. Next slide. So where we're at in the storyline, so now we know there was impact and we know that RDP was now used for lateral movement. You know, what happened before that? Next slide. So again, this is where you're going to look at that 100.23 box. And something you might look at when you open the box, and if we open the box up, you would see it, is, hey, what software is on here? What logs might I be able to look for behaviors? In this case, we picked a remote access solution. So it's oftentimes not practical to just say, hey, let's get rid of Logman, let's get rid of TeamViewer, let's get rid of VNC or other things. Sometimes you need them because the plants are, you know, you need it because you don't have the manpower, plants are dispersed, there's a lot of reasons. And so as you're investigating this box, one thing you might look at is, hey, let's look at remote access solutions on the box and look at those logs. So what we did for this, and we're not going to name the remote access solution we use, you can probably figure out in a slide or two. But at the time or just before this event happened, we can again pull in those log files and say, hey, here for this specific application, what gets written in that text file every time someone actually connects to the remote access solution is participant added, and you actually get their IDs in there. So you can see, hey, now I have remote access logs that logged in, you know, you have that spike in logins at the same time. So we have another kind of thread of it unwound. Next slide. So again, remote access software, this was used. So again, known attackers, you see some of the Ukraine, some of the Korea Hydro with Kim Suki, and so yeah, another tactic and another way to look at it, which is definitely bringing out those log files, because a lot of them, like TeamViewer, have really good log files if you know where to look for. Next slide. So we know that remote access software was used to get to the box initially. We know there was lateral movement from that jump box over to the HMI, and we know that HMI was used for manipulation control. Let's look at what happened before that. So again, this is where network analysis can really come in, because if we look at 23, we see a spike, and an ICS village just is easier to see because there's not a whole lot of extra comms or users. There's not a whole lot of noise on the network. But what we see around the time of the event is traffic out to this AWS address. And with this AWS address, of course, it's unfortunately, it's TLS encrypted also. We know there was a spike, so we know, hey, this new address reached out. There was a pretty big session, and then it died out. So, you know, here's another piece kind of this intrusion. Next part. And what happened, and this is harder to show, we're showing in Scythe. You can do this with other tools, but what happened and what we did on the ICS village range to do this is we actually simulated spear phishing using Scythe. So we created a binary that when the user ran it, it would grab a screenshot with the remote access creds that you needed to actually connect in, grab a few other data. It would run things like Mimikatz. But this is what was behind this spike. And again, like I said, you don't necessarily know it because it's TLS encrypted. So you're just going to, without the logs, you would just see the evidence on disk. Next slide. So again, more simulated in there, obviously using MITRE Attack. When you look at this deck, here are some things other categories to look at protecting against. Next slide. And so a spear phishing link, and just about everyone does this. But again, something to think about when you look for this type of scenario is, like I said, what can you see on the endpoint? What can you see on the network? Because when you look at the known attackers, just about everyone's using spear phishing in some way. Next slide. And screen capture. So this did take a screen capture, and we'll talk about screen capture in a little bit, a little more. Next slide. So evolution of attack now, and this is the full thing. So, we started out seeing that manipulation and control. We saw the lateral movement, the remote access, and we worked it back all the way to the original spear phishing link that took a screenshot. Next slide. So I'll turn over to Tom now.
Thanks, Dan. So we just went through the attack. We started at the what happened and worked our way back to took all those steps for a reason. We wanted to show the impact and then follow each step in a more technical manner on identifying things from logs, from network traffic. Now we're going to go through 4 main questions from this incident. What happened? What could have happened? What did not happen? And what could be done to reduce the risk of this happening again? So what we do know what happened, somebody successfully compromised the network using real world TTPs. Now we saw the evidence from the network traffic that was captured. We were able to, go through and follow each step along the way. We do know that they gained access to the ICS environment, discovered an HMI with a remote desktop enabled, and they pivoted to it. Again, we saw that via logs. We saw that with network traffic. We were able to recreate exactly what happened. They changed the set point from the video there, and the alarms that were on the HMI. We saw that tank running at about 50%, and then all of a sudden it went and overflowed, and it hit the high level switch and it drained out. While the system was designed with safety measures, nothing critical happened. We didn't have any loss of life, health, safety, anything like that. Nothing got damaged. Doesn't mean the intrusion should not be taken lightly. Intrusion did happen. That we do know. What could have happened? Nothing. Nothing could have happened if the operator did not click on that email. We keep on going back to human clicking on phishing emails or visiting sites. It seems like we're constantly replaying that whole message through various campaigns that we discover. So training is a huge part, and we can go to that highly technical training, for defenders, where we can go through some really detailed training. But when our operators are still, or our network users are still clicking on phishing emails that say, payroll or get your COVID shot here, something, and they're still clicking on them, maybe we should really rethink who is getting trained and focus on some basic training first. Not that the technical training doesn't need to happen, it absolutely does, but we're still fighting off the human clicking on those links. The attacker could have deployed ransomware. As we all know, ransomware is very popular. They could have deployed ransomware. They could have locked up our HMI. Then we could have not had access to anything. They could have changed the set points, turned the pump on, turned the pump off, whatever. Deployed ransomware. Really created a bad day for everything. They could have destroyed files. They could have just wreaked havoc on our processors, our computers throughout the system. They did not do that though. One of the big things is they could have, impacted health, life, safety, and created quality issues by changing the set point on the HMI. They did not do that. They did change the set point. However, when we saw the tank overflow, we did see that high level switch kick on and the pump shut off. What did not happen? A lot of things didn't happen. Like I said, we did not have any loss of health, life, safety, quality issues, any of that stuff. One of those reasons are because when the system was designed, we followed good engineering practices. We followed other recognized standards and guidelines to build that process out. A lot of times when after an intrusion, you follow social media, you follow news and everything, and the sky's falling. Hey, horrible. Well, yes, there's an intrusion. The intrusion was bad. You never want to have an intrusion. But one of the things I think gets missed a lot is when processes are designed, they design them to operate. They design them to create whatever they are, whether it's water, whether it's that widget or food and bev or whatever it is. There's thought that goes into that, and policies, procedures, practices, and everything followed that. Hey, you have this tank that only holds 5 gallons. Let's not put a 50 GPM pump on that thing and make water go all over the floor. No, we need to install high level switches. High level switches. We need to put temperature, transmitters and switches, and we build safety devices into that process. And a lot of times those safety devices do not go through your control system. Some of them are hardwired right to the variable frequency drive, like we saw here. So while the intrusion is bad, try to keep in mind that when engineers designed the processes, while they didn't have a cyber physical design in mind, they had a design that would not go boom when something was changed. Not always the case. Sometimes, the things get overlooked and everything. But keep in mind there are good engineering practices out there. There are guidelines and acceptable standards that people do follow when they design things. What can be done to reduce this happening again? Well, let's take a look at exactly what happened. We had manipulation of control. What we saw the video of the tank overflowing. We saw the video of it draining out. How do we prevent it? Well, we can limit the traffic to and from the zones. Audit your systems, harden your critical systems. How do we detect it? Network monitoring, review of logs, things of that nature. Dan, you want to take the next one?
Yeah, I can take the next one. So with the RDP, right, we saw that pivot from the entry point to the HMI. And here, how to prevent is obviously looking at who's in the RDP user group. So things you can do in Active Directory, plus limiting or watching traffic from zone to zone, right? Even if you subzone your network. As we showed, the detection 4624, the Windows event logs are good if you have those. And really also getting into the profiling the user behaviors. And I'll note that you can even do this if you have shared accounts. So like some of the plants that we would do threat hunts in, we had to do a lot of user profiling because for safety reasons, right? You would have a lot of shared, single profiles. So depending on the part of the process or the process itself you're in, you might really get a lot of value out of behavior analysis. Tom, I'll let you take remote access.
All right, remote access software. So we recognize that you're going to use remote access software for many different reasons. During Dan's slide, he mentioned some of the commercial solutions out there. While generally it's a bad idea to use these commercial solutions in the way that we used them here and the way some other recent intrusions happened, we also recognize that, hey, if you're a small manufacturing site, small utility with 10 people, one HMI, one processor, you're not maybe going to be totally tech savvy. It's a solution that met your needs. We recognize that. Is it a bad idea? Absolutely. Instead of hounding on, no, you should not do that. Okay, let's educate people why you should not do that. Let's give them a different solution to do that. Because people are going to take the path of least resistance most of the time. They're going to install those commercial products on there. They're going to leave their network flat, and so they can get to it easy. Why? Because they only have, say 10, 15 people in a whole plant, and they got to provide 24/7, 365 coverage. How are they going to do that? They're not computer people. They're not InfoSec. They just need to make this process run. I come from a process control and utility background that I worked with at plants, at utilities. I've seen it. Said it's not ideal by any means, but it happens. So let's go and focus on, hey, it's not a good idea. Here's another solution that will get you what you need easier, more secure. But what we saw is the attackers come in via a remote access. We saw that in the network traffic. We saw that in the logs. How to prevent it? Limit the scope, monitor and limit the scope of where you can access remotely. Two-factor authentication, segmentation in your network. We just heard before from Enclave about microsegmentation. We heard from Chris from Garland about network monitoring, network visibility. So, when you start including some of those technologies into your remote access solution, you are going to become more secure, and it's not that big a lift to do that. Yes, I just said that you only have 10, 15 people in your whole plant. How do you do that? That is a problem that everybody's trying to work through. How to educate, deploy, implement these solutions to a plant that doesn't have a whole lot of budget, doesn't have a whole lot of money to make these things work. Dan, back to you for spearfishing.
Awesome. Yeah, so for spearfishing, we saw initial access go through that. Big areas, obviously, user awareness training, making sure people are ready. But again, and also really, again, knowing the shape and behaviors of how email is used. So it could be, or it's possible that your network might only be outbound email, or you might actually have inbound. So understanding things like that, hey, where should I see outbound email? Where should I see inbound email? And where is email even used? Prevention wise, that can help where to either tighten it down or moving to the detection side, what to look at. As we showed too, looking for that newness in odd DNS and HTTP, like we showed with the AWS, you only unfortunately saw it in TLS. And then looking for account usage. So again, if someone hops on, generally the next thing they're going to do likely is going to be to try to harvest credentials. And so looking for credential harvesting and some of the secondary effects you see there. I'll go ahead and take screen capture too. So screen capture, we saw that with the remote access creds of the network. Honestly, this is challenging to prevent because it can be a built-in feature. This isn't something, even with strong app whitelisting, you might get around if a feature does have it. And it's also challenging to detect because if it goes through that HTTPS link, you might not actually see it go out. So it's hard on the network side. On the host side, you might be able to monitor the clipboard or do things with other EDR type solutions. Or you might even look for binaries with those screenshot capabilities and look for signs of those being run. So Tom, back over to you.
Absolutely. So that concludes our talk for the day, for this session. We are unfortunately out of time, but if you have any questions, by all means, pop them in the chat. Since I'm the moderator, I can So read that chat, and Dan and I will do our best to get back to you on anything. Thank you, Dan, for doing this presentation with me, and thanks everyone for joining.